What are those? Do you do geography in Scotland?
Yeah.
Huh? Those are the Jura Mountains. They're 1,800 meters high. Okay guys, so this is CERN's council chamber.
Of course, if you add up all the energy in two beams in the LHC, that's not a lot more, because you've got gazillions of protons in the beam. And at full intensity, the LHC beam energy, adding all the protons together, is something like that of a jet plane taking off from the runway.
In which case, I'm sure if you said to him, I've just got this burning question, okay, I'm sure he wouldn't mind answering you.
No.
He's not difficult to spot in the restaurant. All right?
Is this live data?
The ones that are coming up on there?
Yeah.
I wouldn't imagine, no, I don't think they're injecting at the minute. So you see this kind of screen second to the right?
Yeah.
This tells you about what the LHC is doing at the minute. So they're two different colours, the red and the blue, tend to be beam 1 and beam 2. So they'll be injecting them and then they make sure they're stable. Sorry.
And obviously if you work here, look, beer.
Coffee and then beer.
Goes with the job.
Why would they come to start?
Everybody say, big boson.
From Glasgow, and they're not doing the run, when they're not controlling the run. There's like 2,990 of them who are not actually doing that. Wonder what they're doing. We'll just go up here because it's quite interesting. There's lots of possibility to do video conferencing. Yeah, so that's all the noise that we can hear are the vacuum pumps. But you can imagine the vacuum in the accelerator in the LHC is a better vacuum electric field generator, but they're over there, the far side. The particles come in the far corner, so we will not send them anywhere. They'll just send them into a tunnel.
Are these just unmanned or do those have people?
No, that's a lot. And I have to, they wants to monitor my exposure to radiation. To you guys, it's not a problem. You guys get excited about their experiment, the big LHC experiment. There's lots of cool stuff that's done at CERN, which is not primarily associated with the LHC. But here, it's not the bottle of hydrogen, but the fact that they don't allow ladies to clean at CERN. It's a very sexist label, that. It means you can't clean inside.
You thought it meant no witches.
Here's the bottle of hydrogen. There you are. All the hydrogen, all the protons start from this bottle. Am I telling the truth? What?
That's a model.
It's a hydrogen bottle. It says H2 on it. Is it the real hydrogen bottle? No, because look. Okay. It's a fake hydrogen bottle. It's not a fake hydrogen bottle. The real hydrogen bottle is inside this Faraday cage, because there's 90 kilovolts on that, and you don't want that exposed. And it's there that the protons are split away from the electrons in something called the duoplasmatron, which is described here. And when they come out here, what do you think the energy of the protons is when they actually come out of this box? Now this is a very interesting device. It's called a radio frequency quadrupole, and it does two things. Then the particles come to this linear accelerator, 30 meters long, and by the time they get to the end, it's 50 million electron volts and 90,000 kilometers per second when they get to the end. They're being accelerated not by a static electric field, but by a radio frequency electric field, an oscillating field, which means half the time they will be accelerated and the other half of the time they will be decelerated. So you have to shield them from the decelerating field. So you put tubes, just metal tubes inside this tank, and then when they're inside the metal tube they don't see the field and they drift, and then across the gaps between the tube the field is the right polarity and they get a kick, and then they drift, kick, drift. The tubes get longer in that big orange thing. Why do the tubes get longer? Good. And you drill some holes in the bottom. Now unfortunately this means that you will not be able to recycle the aquarium through your biology department, okay, to keep fishing. Never mind, but you will be able to attach some felt to the bottom, some absorbent material, felt. So the felt with isopropyl alcohol, propanol. When you construct yourself a wooden box like this, you line it with polystyrene and you put some aluminium foil on the bottom, so that when you turn over the aquarium it fits inside the box. Okay? Now we're not talking about micron precision here, like we place the magnets around the LHC ring. I am not renowned for my ability to construct wooden boxes, but I think I could probably make a box that will fit these specifications. Alright? Is you construct a metal plate, a black metal plate. This is anodized aluminium. Okay? And if you're really good at this sort of stuff, you can cut a groove in it so that when you turn the aquarium over, it sits in the groove, which means that you can fill the groove with isopropyl alcohol, and then you can make a really nice airtight seal, which is important. But there is an alternative to all of this. Okay? There isn't an alternative to this, not for this type of apparatus. And the final ingredient is dry ice, what my two friends have collected for me. Okay, dry ice. You put the dry ice in the box, you put the metal plate on the dry ice, you fill the channel with alcohol, you have wet thoroughly the felt, and you turn it over, everything's sitting on the dry ice now, and then you wait for 20 minutes while it gets to thermal equilibrium, and that's what you're going to do. So we can make, why don't we make 3 of these guys, okay, and we see what happens. When they're finished, when we're ready, we close the curtains carefully, we illuminate our torch, turn off the light, pray, look inside your cloud chamber and see if you can see some cosmic rays. Okay? You do that?
Yep.
Good. Safety.
And
let's take some nice photographs while you're doing it.
Lots of night inquiries.
Brilliant. A scientist.
Just wash your hands after.
That was my fault. Well,
He's just suggesting.
on the plate, on the ice, before you put the down. Be careful of your hands.
Oh, yeah.
Select this, yeah.
Good work.
They put that on top.
And that's been soaked,
Now-
yeah?
Yeah, we've soaked up.
Now, how do you know? Watch me. Stop and watch me. If when you tip the aquarium, there's a little pool of alcohol in the corner, that means it's okay. Then you can tip the alcohol back into the bottle, okay? I think that is not anywhere near wet. Is it wet enough?
There's a wee bit.
There's a wee bit. There's a wee bit. If there's a wee bit, then you're okay. Make sure you have enough in your channel. Your channel is dry. It's like the desert of the Sahara. What's happened here? Is that flat? Okay, come in. Bring it on.
Go, go, go! Let's find us some neons.
Maybe poo.
What's that?
How's the propyl alcohol?
Yeah, we can sort you
See
out.
how
with
wet
that.
this is now?
How are you?
Excited.
How's your cloud chamber?
Huh?
How's your cloud chamber? How's it going?
It's coming together.
Bam.
I like your glasses. Super cool, man.
So
Excellent
when you
job.
be a theoretician. Very good. Now you have to fill the channel. Whoa! Whoa! My goodness me.
It's been done.
Fill your
This one.
channel.
This one.
Carefully,
Across the top.
Fill your channel.
Yeah, it's pretty good.
No, no, the channel. Sorry, apologise.
Well,
Going up with that. Yeah.
okay, off you go.
And this is what I'm
Roll it.
Yes. It's soaked.
Okay, what's going to happen to the alcohol that's soaking the felt? Okay, so the muon comes flying through. Remember, it's ionizing, it's charged. So it ionizes the atoms of the isopropyl alcohol, kicks out electrons, and this is enough to cause the phase transition, and little droplets of liquid form along the path of the particle, along the path. And that's what you see. They're white, that's why the plate is black. So you see little hairs this long and then some centimeters long if we're lucky. And that's what we're looking for. So you have to look just above the plate, you have to locate the vapor, and then you can see these tracks going through if we've done a good job.
That was one.
Okay, can you speak English to me? Now, one of the problems, you're seeing one of the problems, if you want to take a photograph, it's like recording the event. Bubble chambers, you couldn't really trigger them. Okay? You can't select what you're looking at. You just took photographs and you got what you got. But nevertheless, they're very cool devices.
Are all muons identical?
In principle, yeah, they're supposed to be.
You could actually use a radioactive source if you're allowed to do this in Scotland. You could use an alpha source. Teachers, can they use an alpha source?
Yes.
Could you hold that bit there?
Yeah.
Brilliant.
Okay, it's getting time. Well, if you were back in the 90s,
Oh my god.
Spooky. Right, take the plate out.
Could you put water on it? It would be fun. Isn't it?
Punch it.
You won't do, cause you know that you just might. I'm alive this evening. It was love at first sight.
you. Thank you very much.
Hope you enjoy this. And yeah, it depends. I mean, if you just like we're having the Moses post-Christmas, or at the end of the year, it stops for Christmas in the first few months of the year. I think we'll have anything.
Merci beaucoup. Très bien, voilà. Hey boys, are you enjoying it, boy? All right? Sorry. Right, you get him as well, miss. Yeah. I want you to say, Town of Trino. Brilliant. Cool.
If a train's going at 200 miles per hour, how come the speed of light doesn't go an extra 200 miles per hour?
What's your answer?
I don't know. The light slows down. Because it doesn't. Because God says so.
God says so. Bingo. Everybody bunch in. Bunch in. Some kneeling in the front. In the front.
Bunch in, come on.
You as well, down the front. Keep going. That's it. I've got it all in.
Pose, ready, steady, pose!
Yay!
Wonderful. The guy who's boss of this experiment is a guy called Professor Sam King. He's a Nobel Prize winner. I don't know whether he's here today. He got a Nobel Prize in the 1970s for discovering the J-psi meson or the charm quark. So there is beam in the LHC, but
it's like a zoo.
I don't think they're doing, I'm not sure what maybe they are doing physics. The guy in CMS said yes, so maybe they are doing physics, yeah. But if you look very, very carefully, so there's a lady in the black t-shirt. There's a white box, and then to the guy there's a white box to his right as well. Okay, you can see that? And on that white box there's a red switch.
Yeah.
Did I tell you about this? When I brought Buzz Aldrin here, I said to the team leader, shift leader, is there a big switch to start the LHC? And knowing that there wasn't, and he said no. How do you think they start the LHC, by the way?
Everybody presses all the switches.
2 switches, 2 people.
Nice idea. It's actually a mouse click. You just bring up a program on this desk in the center here, and you bring up a program on there, load some database, click go, and if everybody else is, if everything is green, which it is green at the moment, you can see over there, then it will start. It just runs.